Okay, so in the last class, what we discussed is about the interpreters and compilers, the types of high-level programming languages. Now, today what we will discuss is about the structured approach to programming and, if possible, some part of the flowchart also. So the structured approach to programming is there is actually when we are doing some programming, that is when we are having a specific problem and we want to create a specific program for solving that particular problem, or for as a solution to that particular problem. Then what we do is we doesn't start randomly. That is, we doesn't start programming it straight away. But what we do is there is a structured approach. That is, there is some specific process that is to be followed for programming, and this particular process makes the programming easier also. That is, understanding the concepts, how to solve each particular specific problems inside the larger problem, etc., etc. So that is the structured approach to programming. Then the structured programming is a set of design and implementation processes that yield well-structured programs. That is, there is a set of design and implementation processes. That is, when you are creating, when you are trying to write a particular program, you have to design that particular program first. That is, design the program in such a way that what should be the different variables that will be present in that particular program, what should be the different modules in that particular program, etc., etc. Like when you are using this Microsoft Word, you might have used Microsoft Word. There is a specific module for opening the file. There is another one for saving the file. So they are separate modules, and in the toolbar, in the top menu bar itself, there are different menus available. Each menu is a separate module. So that's sort of how it is, that particular program is to be designed, and where it should be placed, what should be the variables, what should be the modules that should be present, how this program should be arranged, etc., etc. That is the design phase. And in that is the design phase should follow a specific processor, so that a well-structured program will be available at the end. So under the implementation part also, which one should you do first, and which particular part should you do first, and the next what should you do. That sort of what you say, non-written rules are there. It is not written rules, but if you follow this particular procedure, this particular processes, you will get a good program. Good program in the sense it should be very much readable. Readable in a sense that when you write a program, and even after some few days, if you look into that particular program, you must understood what you have written in that case, in that particular program. In the case of large programs, what happens is it takes almost some years. Sometimes it may take months and years to complete that particular program. So at the end, when the programmer looks into that particular program, he may not understand what he has written at the first. But if he follows a structured programming approach, it will be easier for him to understand what he has written. So that's the condition with this structured programming. So it is a disciplined approach to programming. The structured programming is a disciplined approach to programming. That is, you have to follow some specific rules and procedures. Then it follows the top-down design. The top-down design, actually what it considers is, at the first what we consider is about the whole program, the entire program. Then we divide that particular program into sub-programs or sub-modules. The large module, the largest module, the largest thing, the largest problem that you have to solve initially, that we will consider first. Then what we do is we divide that particular problem into sub-problems. Okay, we will see an example after this discussion. So then stepwise refinement using a structured set of program structures. So there is some restricted set of program structures. There are actually three different set program structures are present. And using only these three program structures, we refine the entire problem into small parts. That is, each larger problem will be solved using only these three structures, program structures. And the program structures are sequence, choice, and loop. These are the three program structures that is present in any program. So sequence, choice, as well as loop. Even if you look into any high-level language programs, these will be the three structures that is present in that particular programming code. So we will see one by one. Before that, what is a top-down design that we will see? See, in the top-down design, what happens is the program is divided into main module and its related modules. That is the main module, the largest module. The largest module, then each main module is divided into small modules. Like in our Word program, if you see the Microsoft Word, it is a program, that is the main module. And in that main module, in the top, there will be some menu items will be there, file, edit, etc. Some menu items will be there. So those are the level 1 modules. That is module 1, module 2, module 3, etc. That is file is module 1, edit is module 2, etc. Then within that module 1 itself, if you expand that particular menu item, that file item, you will see sub items. New is another member of this main module, not the main module, the sub module file. So in that way, there will be a new will be there, open, save as, etc. Recent files, about the program, etc. will be there. So those are the sub modules. So likewise, each module is divided into sub modules. So that is happening. And then this procedure of dividing each module into sub modules is continued till there is no further division is possible. So we cannot divide if we at the end we reach a stage where we cannot further divide a module into sub modules. So that is the end. So in the case of this program, in the case of Microsoft Word itself, you will see such a case with its main menu. So that is the top-down approach. In the top-down design or the top-down approach to programming, what we do is we consider the main module first, then the sub-modules, then we divide the sub-modules into sub-modules, then we divide that sub-modules into, if possible, we divide those sub-modules into again sub-modules. So that level of abstraction continues till no further division is possible. So now let's see the stepwise refinement in the case of this structured approach to programming. So this is an action. This entire thing is some action, some specific thing is happening, some specific action is happening in that particular program. And in that what are the sub actions are, initialization is a sub action. Initialization can be, say, we have a variable x is initialized to say 0. So that is an initialization. That is that particular value is given for that particular variable. That is x is given a value 0. So then we check a condition. Say x is less than 10. So that is a condition where x is less than 10 or not. If x is less than 10, that is a condition checking. And in the condition, it is checking whether it is true or false. If true, something has to happen. And if false, something else has to happen. So if it is true, action x is to be happen first. Action x is, again, it can be again subdivided into condition x as well as action y. Again, another condition can be here. And then depending on that particular condition, whether it is true or false, some action may happen or may not happen. So that sort of abstraction, that is each action is divided into sub actions. It is here the action x is divided into condition checking x as well as the action y. So that sort of abstraction, that is how we are refining the program into sub-modules. Then once this sub-module condition is done, that is abstraction is completed, then we start coding for each particular module, a small module. And this is actually taken from a small module itself, not from the, what do you say, the module-wise refinement condition. But this is applicable to module-wise refinement also. This is taken for stepwise refinement. Then action, in this case, once say x is less than 10, we have checked that since x is 0, x should be less than 10. So this condition is true. So this particular action x happens. Then what happens is it is an updating. We are updating x equal to x plus 1. So x is increased. Then again, this goes back to this condition checking, whether x is less than 10 or not. So this is how the stepwise refinement happens. So this is actually a loop. This is actually a loop structure. So any action can be another sequence, choice, or loop. That is the condition. Any action in a particular program can be either a sequence or a choice or a loop. So, and any division or any refinement of an action into sub-actions or sub-actions can also be a choice of or a combination of these three, that is a sequence, choice, or loop. So let's see what is a sequence, a choice, or a loop. We have already seen what is a loop, how it is happening. So again, we will discuss it once more. Sorry. So a sequence is a continuous set of actions. That is, action 1 is happening, then action 2 is happening, then action 3 is happening, then again some action n is happening. So this goes on. That is a continuous set of actions is a sequence. That is, there won't be any condition checking in between, there won't be any looping in between, or actually even if there is a looping in between, that looping can be clubbed together to a single action. That particular loop structure can be considered as a single action. So that is a sequence. So in the previous case, if we consider this initialization condition, and then after that condition, whatever happens here, so that can be this particular condition checking, action x, and update. These together, these three things together can be taken as another action. So this initialization is an action. Then these three things together can be considered as another action. And then if there is something further, that also can be considered as another action. So that sort of continuous processes or continuous actions is known as a sequence. So this is one of the important structure in the case of programming. Then a choice statement. A choice statement, we have already seen a choice statement, that is a condition, whether a condition x is greater than, less than 10. In the previous case, we have seen here, we have seen this particular condition. This one we have seen x is less than 10. That is a condition checking, whether x is less than 10 or not. So if it is true, that is, if x is less than 10, then some specific action is to be done. And if x is not less than 10, that is, say, when this loop iterates through some 11 times and then x becomes 11, because in each iteration x is increased by 1, x is increased by 1. So after 11 iterations, the x becomes 11. So in that case, x is not less than 10, or x becomes 10 itself, then also x is not equal to and not less than 10. So in that case, this particular condition becomes false. So it goes to some other statements, some other actions. So that is the case. That is, in a condition, we are checking whether a specific condition, whether a specific variable has a specific value, or whether that value is less than or greater than a specific value, etc., etc. That condition can be anything. So we are checking a specific condition, whether a specific variable is having a particular value or not. That is it. So in most of the cases, it is the case. So and if it is having a specific value, then or specific range of values, then a specific action. Then if it is true, if that particular condition becomes true, then a set of action is to be done. A set of action is to be done. If it is false, we have to bypass that set of action. That is a choice statement, a type of choice statement, in which case if it is true, some action is to be taken, and if it is false, no action is to be taken. So if the condition is true, then we execute the action. So this action can be again either a single statement or a group of statements within braces. That is, this action can be having sub actions also. That is, this action may also have to refine, may be refined to sub actions. So that is the case. That is, in the case of a condition statement, we are checking whether if that particular condition is true or false. If that particular condition is true, some action is being done, and if it is false, no action is being done. So that is a type of choice statement. And another type of choice statement is that here. That is, in which case, if it is true, if the condition is true, the action A is being performed, and if it is false, action B is being performed. So that is also possible. This particular condition can have two options, whether it is true or whether it can be false. It can be either true or it can be either false. If it is true, that action A is being conducted. That is, it is taken, executed. This action A is executed. And if if the condition is false, if condition becomes false, then the action B will be executed. So that is the second type of choice statement. So the choice statement can be two types. One is true having some specific action and false having no action. And another type is true having some specific action and false having another type of action. So there is another, a third one is also possible. That is, true is having no action and false is having some action. That is also possible. So there are multiple types of choice statements are possible. The syntax of writing this choice statements is like this. If condition, we have to give within bracket what is the condition that is to be considered. If condition, that is, if condition means if condition is true, we have to perform action A. And if condition is false, we have to perform action B. So that is it. If condition is happening or if condition is true, action A, and else, if condition else means if condition is false. If condition is false, the action B is to be happen. So this statement is equivalent to these particular statements. If the condition is true, execute action A. Else, that means if the condition is false, execute action B. So that is a choice statement. Then a loop statement. There are different types of loop statements, and one of them is a while loop. While loop means we are checking a specific condition. That is, while a specific condition is being satisfied, say x is less than 10. We are considering a variable x. So while this particular variable x is less than 10. So if that particular condition is true, this condition is true, then action is taken. So this is the case. Here x equal to, we initialize x as x is equal to 0. And then in the condition we are checking x is less than 10. Then if it is true, what happens is x is equal to x plus 1. So we are incrementing x by 1 as the action. There may be another actions also. And along with all those actions, we does this action also. That is, we are updating the value of x. X is incremented by 1. So then again it is coming up here. So now the x is 1. Now the x is 1. Now again it is checking x is less than 10. X is 1. So 1 is less than 10. So again this action is happening. Then x is again incremented. So x becomes 1 plus 1, that is 2. So x is becoming 2. So this way it repeats until x becomes 10. When x becomes 10, x is not less than 10. X is equal to 10. So that is that becomes, this condition becomes false. And when that particular condition becomes false, it goes to the else statement, that is the next statement that it has to execute. So that is it. If condition is true, then execute the action. Repeat this process until condition evaluates to false. Action is either a single statement or a group of statements within braces. So this action can be a single statement, as I shown here. Here only a single statement is shown, but there it is a possibility that there is multiple statements is also possible. So that is a looping statement, and the looping can be a while loop is there, and another types of loops are also there that we will see later. Later when we are doing our programming part, we will see what are the different loop statements available. So we will see another loop statement also, that is a for loop. In a for loop, what happens is, in the case of while loop, we initially does not know how many times this particular loop will run, because at some specific time, sorry, this is not this one. Yeah, we doesn't know what actions this is happening at some point of time. Say if it has some statement like this, x is equal to x by 2, some statement is like this in this action statement, then what will happen? X equal to x plus 1 is we are adding up, but x is at some point of time x is becoming x by 2. So obviously we doesn't know how many times this particular loop will run, because at some point of time x has to become 10 or at least equal to 10, otherwise this particular statement won't become false. So we cannot find out that how many times this while loop will run until we run that particular program. So that is the problem with while. The number of execution of this particular loop, this particular structure, repetition, we doesn't know initially. So that is it. But if in some cases we need to execute a number of statements, a set of statements for a specific number of times, say 5 times we have to execute. So in that case, what we use is we use a for loop. In the case of a for loop, for this much time that is, we execute, say x equal to 0, condition x is less than 10, and x plus means this implies that x equal to x plus 1. So each time what happens is x is being initialized, as well as x is initialized first, then the checking is done, then x is incremented, and then what we does is, within this particular looping structure, we doesn't increase that particular value of x again, we doesn't use the value of x again, or we avoid using, if possible we avoid using the value of this particular x. And in some cases we need to use that particular x also, because depending on the number of on which number of iteration it is being run, some value has to be updated. So that also we have to take. Okay, that also we will see in the later lectures. So then this much time, that is x is 0, x is less than 10, that is 10 times this particular action is being repeated here, irrespective of what is happening to x. We doesn't change the value of x within this loop. If it doesn't change the value of x within this loop, this will run exactly for 10 times, and on the 11th time it exits. So that is how this for loop is working. So it execute initialization statement while this condition, again while this condition is true, we execute the action, and then it is being updated. So this is another type of looping statement. There is another third type of loop statement is there, that is a do while statement. In the details of these things also we will see when we study the programming. In the case of do while, what happens is the action is happening first. In the case of while statement, what was happening is the checking was happening first. We were checking whether this particular condition is true or false, then the action is being happened. But in the case of do while loop, what happens is we are doing the action first. Then once the action is completed, we are checking this particular condition is true or false. So that means the action will happen at least once in the case of a do-while loop. But in the case of a while loop or for loop, there is a chance that the action is never done. That is, if the condition is false in the first case itself, if it is a while loop, if the condition is false in the first instance itself, then that particular action will not happen. But in the case of a do-while loop, what happens is the action is happening at least once, and once that particular action is happening, then only the condition is being checked. So that is the importance of this do-while condition. So we execute the action in the case of a do-while loop. Then if condition is true, then execute the action again. If it is false, then we stop executing that particular action. Then repeat this process until this condition evaluates to false. So action is either a single statement or a group of statements within braces. So this action can be either a single statement or it can be a number of different statements possible. So let's see an example by which we can understand the condition of refining the statements or refining the actions of a problem. So suppose we have to print out a diamond pattern. In this case, these type of problems are coming up in your programming exercises. So you have to print out the following diamond pattern. That is, in the first row, there will be only a single star will be there. And in the second row, there will be 3 stars, then 5 stars, then 7 stars, then 9 stars. Once that 9 stars are printed, in the next line, there will be only 7 stars, 5 stars, 3 stars, and 1 star. So it will create a diamond-like shape. So this is a diamond-like shape, diamond type shape. So this is to be printed, and how this particular problem is divided into this sub problems. Let's see. So the main problem is printing the diamond pattern. Then the sub problems, there will be 2 sub problems. One of the first sub problem is printing out the upper half, that is this part. Printing out this part is the first sub problem. Then the second sub problem is printing out this part, that is the lower part. So this 2 constitutes the total diamond pattern. So the first sub problem is printing out the upper half, and the second sub problem is printing out the lower half. And in the upper half, what we need in the upper half is to be again subdivided into sub problems or sub to sub problems or sub to sub actions, actually sub to sub actions. In that case, the row 1, in the row 1, what we have to do is we have to print 4 spaces and 1 star here. This dash indicates the spaces. Actually, if I put spaces here, you will not be able to visualize it. That's why I have put space dashes here. So these dashes represent spaces. So in the first row, it requires 4 spaces and a star. In the row 2, 3 spaces and 3 stars. And in the row 3, 2 spaces and 5 stars. And in the row 4, 1 space and 7 stars. And in the row 5, again, there is only 0 spaces and 9 stars. And in the row 4, you have to repeat this one, that is repeat 4, the 4th row, that is 1 space and then 7 stars. In the row 3, again, you have to print 2 spaces and 5 stars. In the row 2, you have to print 3 spaces and 3 stars. And in the last row, we have to repeat again the row 1, that is print 4 spaces and 1 star. So the lower half is actually a repetition of a reversed representation of this first part of, or the first 4 lines of the upper half. Then let's see how this can be implemented. So the algorithm for the first half or the upper half will be like this: print 5 minus row. Row is the number, the row number. So in this case, row is 1. So 5 minus row, 5 minus 1, that is 4 spaces, and 2 into row, 2 into 1 minus 1. 2 into 1 minus 1 is 1. So 1 starts. And that is 4 spaces and 1 starts. And in the second row, again, 5 minus row is here 2. So 5 minus 2, 3 spaces. In the previous case, it is written like that, 4 spaces and 3 spaces. In the first line, it is 4 spaces. And in the second line, it is 3 spaces and 3 stars. Here it is 4 spaces and 1 star. So here, 5 minus row means 5 minus 1. So 1 space, 4. 5 minus 1 is 4. 4 spaces and 2 into row, that is 2 into 1. Minus 1, that is 1. 1 stars. So 4 spaces and 1 star. In the second row, print 5 minus row, 5 minus 2, that is 3. 3 spaces, and 2 into row. Row is again 2 here. So 2 into 2, 4. 4 minus 1, 3. 3 stars. 3 spaces and 3 stars. So in the row 3, print 5 minus row. 5 minus row spaces. Row here is 3. So 5 minus 3 is 2. 2 spaces. Here is 2 spaces. And 2 into 3, 6. 6 minus 1, 5. 5 stars here. So this repeats that this particular statement, that is print 5 minus row and 2 into row minus 1. This is the same. This is the same in such a way that this particular value, this row is this row number, the number of the row. So this a repetition of the same thing is being done with an increment in the value of row. A repetition of the same thing with an increment in the value of row, that is happening. And in the lower half, what happens is again, this is again repeated. Row 4 is repeated, row 3 is repeated, row 2 is repeated, and row 1 is repeated. That is in the reverse order. These first 4 rows are repeated in the reverse order, in a reverse manner. So let's see how this is being done in C programming. I don't expect all of you to understand the complete concept, but at least you try to understand what it is. So into row, space, and star, we are actually defining 3 variables here. Row will take the row number, and space will take how many spaces should be there, and the star will take how many stars will be there. So for row equal to 1, row less than or equal to 5, row plus plus. That means row is initialized as 1. The first row number is 1, and the second row number will be 2, etc., up to 5. Row will be less than or equal to 5. So the row number will be up to 5, row 1 to 5. So in the previous case, see, the value of row changes from 1 to 5. That's it. So for that one, we are taking row less than or equal to 5. Then each line, after each line, row value will be incremented by 1. As I said previously, that is, the row is increased by 1. Row equal to row plus 1. That is written shortly as row plus plus. And then another for loop is happening here. That is, since it has to print some number of spaces, again another for loop is happening. So here is 4, space equal to 1, space less than or equal to 5 minus row. We know that the number of spaces is 5 minus row. So the number of spaces should be 5 minus row. So that is why it is taken as 5 minus row here. Then space plus plus. Space is increased by 1. So then printf this particular space. The space character is printed. Then the star character is to be, once that particular for loop is completed, this particular for loop is completed, it has to go to the next for loop. That is, it has to print the star. So for star equal to 1, star less than or equal to 2 into star 2 into row minus 1. Here the number of stars is 2 times row minus 1. So 2 times row minus 1 stars are to be printed, then star plus plus. So then it is printing the star. So once these 2 lines are executed, that is, the space are printed as well as the stars are printed, it has to go to the next line. It has to move to the next, sorry. So here, once the 4 stars and four spaces and 1 star is printed, it has to move to the next line. So then only the second line will come up. So that is why this particular line is here. This particular line actually prints, carries this particular, the position to the next line. So then here, in the second, this is the top half, this particular lines, not this much, only this much. This is the top half, and in the bottom half, the row, the first row will be row 4. See, the first row is row 4, then row 3, 2, 1. That is the reverse of this one. So what we do is we initialize row to row 4, and we check whether row is greater than or equal to 1. Then we decrease the row by 1. Row by 1 in each of the iterations. So then this one is repeated. First we print the number of spaces, 5 minus row number of spaces are printed. Then 2 times row minus 1 times the stars are printed there. So this is repeated. So that is how we get to this particular star structure, star-like structure.